All right, so hopefully you had time to do the first task and you know the answers to all of these. So on the left, we have this red one, which is represented by x squared plus 6x. And over here, we have g of x, which is x squared minus 14x plus 40. Our first question says, what are the zeros or x-intercepts of f of x, so the red one, from looking at the graph? I should actually make this red, right? So that they match. So what are the x-intercepts of f of x from looking at the graph? Well, the x-intercept is where it crosses the x-axis. And I see it crosses the x-axis here at -6 and 0. So I have -6, 0, and 0, 0. Now it says, what are the zeros or the x-intercepts of g of x? Okay, so again, it's where the graph crosses the x-axis. So here it's at 10, and here it's at 4. So I have 4, 0, and 10, 0. Now it says, how are the zeros, or the x-intercepts, related to the factored form of each function? Well, I don't know the answer to that because neither of these are factored, so we got to factor them. So if I factor this, it's a GCF problem. So I factor out the greatest common factor, which is x. And when I divide that out, I get x plus 6. And we could double check that through distribution to make sure it's correct. And that we would get x squared plus 6x back. And over here, actually I'm going to wait to write that because I have a lot of steps. So over here I'm going to use factoring by grouping. So I'm going to multiply my a times my c value, which is 40. And I'm going to say, okay, what are the factors of 40 that can give me a -14? Well, that has to be -10 times -4. If I multiply a negative times a negative, it gives me a positive. And if I add -10 to -4, it gives me -14. So -14x is going to break up into -10x and -4x. And my positive 40 of my constant is going to come down, and my leading term of x squared is going to come down. So this is called factoring by grouping for a reason. So if I group this into this section, I ask myself, what's the greatest common factor between x squared and -10x? Well, it's x. So I factor out x, and I get x minus 10. And over here, I ask myself, well, what's the greatest common factor between -4x and 40? And I'm going to say 4. But you're going to notice something happens. So if I factor out 4 and only 4, I get -x plus 10. Now see, these are different. I don't want them to be different. So instead of factoring out just 4, I actually need to factor out -4. So anytime there's a negative here in the front, you need to factor that out. So -4, not just 4, and x minus 10. And now we see that x minus 10 and x minus 10 are the same. So that in and of itself is the greatest common factor. So now I can factor out x minus 10, and I am left with x minus 4 from the outside. So now I have the factors. I have x times x plus 6 and x minus 10 times x minus 4. Then I'm looking at, okay, well, I have a -6 here and I have a 0 here. I have a 4 here and I have a 10 here. So my answer, how are they related? All right, sorry, I had to type that out. My computer is lagging. So how are the zeros or the x-intercepts related to the factored form of each function? Well, the ones in the parentheses, if we look at these, the ones in the parentheses have opposite signs when we compare them. So this is a -10, and then this becomes a 10. This is a -4, and this becomes a 4. This is x plus 6, which is going to become a -6. And this is just x, and that becomes 0 if we set it to 0. So that makes perfect sense. So now I'm going to walk you through the example on this problem. So you're going to do the rest of it, and I'm going to walk you through the first one. It is already factored. It says finding zeros using zero product property. When a function is in its factored form, it is very easy to find the zeros. I wonder why that is. Let's see. So it already gives it to us as x plus 11 times x minus 1. And it's asking me to find the zeros. So I'm going to do x plus 11, set that equal to 0. And I'm also going to do x minus 1 and set that equal to 0. Because that's really what it's asking me when it says find the zeros. So over here, I have a one-step equation. I'm going to subtract 11 from both sides, and I'm subtracting it because it's already positive. So in order to cancel it out, I need to make it a 0. 11 minus 11 is 0. So this is x equals negative 11. And the reason I subtracted it on both sides is because this is an equation, and you have to remain consistent. Whatever you do to one side, you have to do to the other. So over here, I'm now going to add 1 because, again, it's the inverse operation. And whatever you do to one side, you have to do to the other. So I get x equals 1 and x equals negative 11. And you can write that as x1 equals, negative 11, x2 equals 1. You could also write it as coordinate. I'm going to put it as coordinate. So negative 11, 0, and 1, 0. And the reason I want to write these as coordinates is because I know that they're related to the x-intercepts. So if I go to graph them, I already know what the coordinate will be. All right, so go ahead and try those problems out.